Hello everyone, and welcome to this webinar on what's new in quantitative finance. My name is Akshay Paul, and I'm the product manager for the quantitative finance products at MathWorks. MathWorks, for those of you who don't know, is the maker of MATLAB and Simulink software, which is used across a variety of industries, including aerospace, automotive, communications, medical devices, and finance. In this webinar, we'll explore the latest trends and advancements shaping the quant finance landscape in 2024. So my objective today is to provide you with a little background on 4 key trends in the industry, why they're important, and specifically what MathWorks has to offer for each one of them. A couple of quick logistics before we get started. Firstly, this webinar is being recorded and will be available to view on our website after the event. Secondly, please use the Q&A window to ask questions during the presentation. There will be a Q&A session after the presentation, and we'll do our best to answer all your questions then. Alright, so as I mentioned, we're going to be looking at 4 key trends shaping the financial services industry this year, namely the rise of generative AI, low-code workflows, climate risk analysis, and navigating regulatory changes. And for each of these topics, I will be highlighting some of the recently added MATLAB functionality. Let's start with generative AI. So by now, I'm sure everyone has at least heard of Gen AI, if not used it over the last couple of years. And the difference between Gen AI models and traditional AI models lies in their ability to generate new data similar to the data they were trained on, hence the name generative AI. They capture the underlying distribution of the data, which allows them to produce novel instances. There's a lot that falls under Gen AI, and I won't go into each of the areas in detail, but I'd like to call out a few that are relevant to quants and to the financial services industry in general. Some of the most common types of Gen AI models today are GANs, BAEs, RNNs, LSTMs, and GPTs. GPTs have been getting the overwhelming focus and attention over the past year or so. That's just based on the number of applications and domains that they can be applied to. However, a lot of the other models are also used for financial applications. I'm going to go through those in a little more detail. Alright, so what you see here is a general overview of the different applications of these models, and specifically within financial services. And amongst these 5 models, 2 that stand out because of their high prominence are LSTMs and GPTs. LSTMs are a specialized type of RNNs, a recurrent neural network, that can capture long-range dependencies in sequential data and have applications in time series prediction and algorithmic trading. GPTs, on the other hand, leverage the transformer architecture and large-scale pre-training on text data. Some of their applications within finance are for reporting, customer service, and compliance monitoring. So at MathWorks, we've been developing a lot of functionality around generative AI over the last couple of years across MATLAB and the other toolboxes, specifically the deep learning toolbox. There's extensive features developed to train GANs and CGANs, to train BAEs, and for LSTMs in MATLAB. In the last few releases, we've shipped features to locally explain trained models using Lime and Shapley, features for specifying state and gate activation functions for LSTM layers, as well as multiple finance domain specific examples. One such example that shipped this release is transformer networks for time series prediction. And I'm going to be showing you a quick demo of what that looks like.
In this example on transformer networks for time series prediction, we will go into the details of how to model the daily price of stocks in MATLAB. The first step in the process is to import the data. The data contains daily stock prices of 3 stocks for a time period spanning January 2000 to September 2023. Once the data is imported, we can plot it as seen in this graph. The next step is data preprocessing, followed by defining the network architecture. The network architecture is defined using the Deep Network Designer app from the Deep Learning Toolbox. Training options are then defined for the transformer model. Depending on your specific use case, there are many training options available. One way to easily test different network architectures is using the Experiment Manager app. These two screenshots show what that would look like. Once we have all that set up, the next step is to train the transformer model. This can be done using the train network function. Once the model is trained, predictions can be made using that model for future stock prices. We can then visualize model performance by plotting the actual price versus predicted price across the training and testing data. Additionally, performance metrics like RMSE can be computed as well. The last step in this workflow goes over how to backtest the model performance on testing data using the backtest engine and backtest strategy functions from the financial toolbox. The 4 strategies used here are long only, long short, best bet, and equal weight. The summary and equity curve for each one of these strategies can be outputted as shown here.
One final thing I'd like to call out on this topic is the new AI chat playground, which is available on MATLAB Central. This is an experimental Gen AI offering that integrates with OpenAI's GPT models and works a bit like Copilot, where it'll write or edit MATLAB code for you based on natural language instructions. This can save a lot of time getting to grips with the syntax of unfamiliar commands, for example. Let's take a look at how this works.
This is the AI chat playground, which was recently developed and released by MathWorks. On the left hand side there's a chat window where you can enter your prompts, and on the right hand side is an editor where you can write and run your code. It starts off with a few examples which can be seen here. Let's select one of them. So here we want to create a table of 10 landmarks in France and use the geoscatter command to visualize the table. So immediately we get a bunch of MATLAB code which we can then transfer to the editor and run. This code is currently executing in MATLAB 2024A, and as you can see it's plotted points on a map. A couple of other things I'd like to mention is that not all toolboxes are currently supported in the AI chat playground. So if you run into a situation where the code that it suggests is from a toolbox that is not supported, you can always use this copy command to copy the code in the editor and then head over to MATLAB to run it. Lastly, since these models are continuously learning, it's always good to either thumbs up or thumbs down the suggestions to improve future results.
Alright, so moving on, I'd like to cover the second trend we're noticing, which is an increased requirement and proliferation of low-code workflows. Low-code workflows can be defined as any workflow that requires little to no handwritten code. So think graphical user interface, point and click, etc. So in this picture, it's everything that you see in the middle box right there, which is used for exploration and discovery. Some of the obvious advantages are increased speed to get from 0 to 1, as well as more efficient prototyping and experimentation. Another less obvious advantage is that these workflows now allow the user to focus solely on the domain-specific task at hand, and not have them have to bother about things like software design, architecture, and development. The financial services industry has always had low-code implementations for specific workflows. However, the quantity and number of players has just been gradually increasing over time. Specifically within MathWorks, low-code workflows can be divided into 4 different quadrants. While apps and live tasks are both low-code implementations, apps are more heavyweight, designed for entire workflows, whereas live tasks are lightweight, designed to perform a very specific task. Internally, MathWorks has created a number of apps over the years across various toolboxes, which can be found in the MATLAB apps gallery. Users can also create their own apps using the App Designer tool, which ships with MATLAB. App Designer provides an easy and intuitive interface to design the UI as well as auto-generate the code required to interact with the app. Now onto the live task side. There are again tasks that MathWorks develops and ships with MATLAB, and those can be found in the live task gallery from the editor tool strip. And finally, MATLAB users can also create their own live tasks by subclassing the MATLAB task live task base class. Both apps and live tasks created by users can and often are shared on community websites like FileExchange and GitHub for consumption by the wider MATLAB community. Some of the specific apps that MathWorks has created which are extensively used in the financial services industry are the Econometric Modeler app, which is found in the Econometrics toolbox, used for analyzing time series data, developing econometric models, and using them for estimation and forecasting. The Binning Explorer app, which is part of the risk management toolbox, is used primarily for binning numerical and categorical data as a first step in the credit scoring workflow. The Statistics and Machine Learning toolbox is two very widely used apps, which are the Regression Learner and the Classification Learner, and they support a wide variety of ML models used almost in all sectors of financial services. And finally, and this is most recently, the Experiment Manager, which is now shipping with MATLAB, allows you to create experiments to run your code using various parameter values and is used primarily in asset management for portfolio optimization workflows. So drilling down into the more recent features in some of these apps, you can see that the Experiment Manager implemented apply and reset filters in 24A. The Learner apps added functionality around explainability in 23B, and there's also a new app to backtest investment portfolios. Let's see a demo of that app in action.
In this example, I'm going to show you a low-code implementation of the backtesting functionality from the Financial Toolbox. You bring up the app by calling Backtesting app in the command window. Once the app comes up, you can see on the top that it's laid out into 4 different parts: loading the data, defining the backtesting strategy, creating the backtesting engine, and running the backtest. The first step is importing the data. You can either import data from the workspace or from a file, but for the purpose of this demo, I'm going to import a session that was already previously created. The app allows you to visualize what data has currently been imported, and as you can see in this case, it's time series data for stock prices from the DJI index. The next step in the process is defining the backtesting strategy. For this example, I've created 5 backtesting strategies: equal weighted, inverse variance, max Sharpe ratio, Markowitz, and robust optimization. The buttons on the right over here can be used to add, edit, duplicate, or delete backtesting strategies. To take a look at what one of these strategies looks like, let's hit the edit button. A new window pops up which allows you to configure the backtesting strategy by changing a bunch of different parameters, as can be seen here. Once you're done making edits to the strategy, you can close out of this window. The next step of the process is creating the backtesting engine. There are a few parameters that can be controlled for the backtesting engine, which can be seen highlighted here. Following that, you select all the strategies that you want to run, hit the Create Engine button, and then hit Next. The next and last step of the process is to run the backtest. You can define backtest running parameters like the start date and end date before running your backtest. To run the backtest, hit the Run Backtest button. The results get shown in this results panel below. You can switch between equity curve, summary table, and asset area curve for each one of the strategies that have been backtested. Another great feature of this app is the ability to generate code. As you can see, all the operations that were just performed have now been generated into MATLAB code and displayed for you here in the editor window. Going forward, you can make tweaks to the script and rerun the code as required.
Alright, now the third trend I'd like to talk about today is climate risk, or more specifically climate-related financial risk. Climate risk involves assessing the financial impacts of climate change on different business functions. And as a first step, it involves identifying and measuring climate risk drivers, which are broadly divided into physical risks and transition risks, followed by identifying the transmission channels or pathways through which these climate risk drivers propagate, and finally assessing the impact on credit, market, operational, or liquidity risk. Now, depending on whether you're a bank, asset manager, insurance company, or central bank, there's differences in what specifically you care about and need to assess, However, a complete workflow would more often than not involve a process of measuring, modeling, monitoring, and reporting. Climate risk has emerged as a critical concern for the financial services industry in 2024, primarily due to the increased awareness of environmental sustainability and regulatory initiatives aimed at addressing climate-related financial risks. Specifically on the banking side, the focus has been on financial stability, risk assessment, and regulatory compliance. And for asset management, the driving factors are financial impact and long-term performance, opportunity identification, and client expectations. On the insurance side of things, although insurers and reinsurers have actually been doing NatCat modeling for decades, it's just very recently that they've started considering long-term climate scenarios in their modeling methodologies. From a business perspective though, their driving factors are financial impact, regulatory compliance, and risk prediction. Lastly, for the central banking sector, the main reasons for conducting climate risk assessments are financial stability, monetary policy, and global coordination. So over the past couple of years, we at MathWorks have been partnering with leading climate researchers in academia and the industry to develop our own climate risk solution for our customers in financial services. And I'd like to call out a few specific components of that solution split by the same 4 sectors which I showed before. On the banking side, we can assess both physical and transition risks on a loan and mortgage portfolio. On the asset management side, we've implemented temperature alignment methodologies as well as commodity volatility modeling and pricing of weather derivatives. Regarding the insurance sector and specifically for NatCat modeling, we've built MATLAB connectors to a number of climate data providers so users can easily access their data in MATLAB. We've also implemented loss models for flooding across multiple geographies. Finally, for central banks, we've implemented different stress testing methodologies using data provided by NGFS, Bank of Canada, as well as MIT. At a more granular level, here's a timeline of features we've worked on over the last few releases. So as you can see, we've implemented connectors to new data providers like Haver, ICE, JBA Risk Management, as well as NASDAQ RMC. We've also implemented a methodology to analyze physical and transition risks for mortgages, which I will be showing you an overview of next.
In this example, we're going to go over how to assess physical and transition risks for mortgages. The data used for this example is simulated. There are 3 scenarios that are being described here: early action, delayed action, and no action. Looking at the data, we can see that it's panel data with residential and commercial real estate price indices as well as precipitation change for each of the 3 climate scenarios. There are a number of steps involved in this methodology. However, I want to focus on 3 major ones: modeling the physical risk, modeling transition risks, and adjusting the loan-to-value ratios. For this specific workflow, we are considering flood as the physical peril. There are 3 flood levels that are being considered: low, medium, and high. And as you can see, sensitivities can be adjusted by using the slider, which is a live control that's available from the tool strip. This plot shows how the adjustment factor is applied to the property value and plotted for 3 of the climate scenarios over time. As you can see, in the no action scenario, the value of the property falls pretty quickly between now and 2040. The next step is to model the transition risk. In this case, we're modeling how energy efficiency rating changes would affect the ability to rent a property in the future. Once again, some transition risk adjustment factors are computed by making a few assumptions, and those are translated into property values for each of the climate scenarios. The last step I'd like to highlight is the loan-to-value projections adjusted for both physical and transition risk. In this case, the adjustment factors for physical and transition risk are combined, and they're translated into loan-to-values for each of the climate scenarios over time.
Alright, so the last trend I would like to cover today is the regulatory landscape. And this has to do with the changing regulatory environment governing financial markets, institutions, and products. It encompasses a wide range of regulations and directives aimed at promoting market integrity, protecting investors, and ensuring financial stability. In terms of sectors within financial services, I'd like to specifically focus on the banking sector with respect to model risk management. So over the last few years, a number of regulations have come down for banks across the world, including SR 11.7 by the Fed, E23 by OSFI, and CP 622 and SS 123 by the Bank of England. Financial institutions are actively working to comply with all these regulations by improving processes around the development, testing, validation, monitoring, reporting, and overall governance of their models. MathWorks has developed our own model risk management solution called Modelscape that has individual products for each one of the sectors of the model risk management wheel, namely development, validation, testing, deployment, monitoring, and governance. This demo provides an overview of Modelscape governance, one of the components of the Modelscape solution.
MathWorks' model risk management solution is anchored by Modelscape Governance, a cloud-based regulatory compliance solution to efficiently manage all models across different business areas. Accessible in a web browser, Modelscape Governance offers users curated lists of models and vital business data. Additional graphical views of the model inventory provide users with a clear understanding of how data and models flow through your institution. Modelscape Governance supports an unlimited number of custom lifecycles to let you govern models, non-models, and other tools, all within a single solution. And each state of the model lifecycle supports multiple triggers for customized automation and notifications, like reminders for upcoming deadlines, automated reporting, and triggers for DevOps pipelines. Managing models involves collaboration across your entire organization, and Modelscape Governance's model inventory is agnostic to specific programming languages, enterprise tools, and document storage locations. Its lightweight configurations allow for seamless adjustments to the inventory as business needs evolve and teams refine their model development practices. Embedded dashboards and integration with tools like Power BI and Tableau ensures data is always up to date when creating reports on key business metrics. Users can drill down into each model and use customized tooling for tasks like calculating risk ratings to each model, which then feeds up to these reports. Modelscape Governance logs every system action to ensure full audit compliance, reducing waste in your organization's reporting and compliance efforts. For more information on Modelscape, visit modelscape.com.
So in addition to features in governance, which you just saw, here are some highlights of features added to all the other components of Modelscape over the past few releases. Most recently, we've updated the architecture of the review editor, added validation live script templates, and added a MATLAB production server interface for Modelscape deploy. Each component of this wheel maps directly to one component of the Modelscape solution, and our development teams are constantly adding new functionality based on the latest regulations. If there is something within the model risk management workflow that you would like to get more information about, please reach out to us directly and we'd be glad to set up a demo. Alright, so going back to what we covered today, we provided an overview of 4 key trends shaping quant finance in 2024, namely Gen AI, low-code workflows, climate risk, and the evolving regulatory landscape, and then highlighted the work that MathWorks has done and continues to do for each one of those trends. So with that, I'd like to thank everyone for listening and look forward to seeing you at one of our future webinars.